Okay, good morning everybody. We've got 3 more lessons on partial fractions this week. Each one of them is significantly shorter than yesterday's lesson, which went on a bit longer than I hoped in the end. So what we have to do is just looking at the different variations of the sorts of questions we can get. So we are going to use, instead of deriving another one, we're going to use quite extensively something we used yesterday. Yesterday we found that 1 plus 2x to the half is equal to, let me just remind myself, 1 plus x, take away half x squared plus a half x cubed. So that's what we found out yesterday, and we're going to use that quite a bit today. So first of all, let's do an example like this. Show that the series expansion of 1 plus x, 1 plus 2x to the half up to x to the 4 is 1 plus 2x plus half x squared plus half x to the power of 4. Okay, you guys can probably have a quick go at that one. We've got a product of two things here. You know what this one is, up to x cubed. Oh, I should probably have the x4 term, and let's just change that. Sorry, let's just get rid of that one because we haven't got the x4 term there. Make that x cubed. So you know what this one is, up to x cubed, so you can multiply these two things together and show that up to x cubed you get this amount. So have a go at that quickly. Pause the video. So hopefully you've said that 1 plus x, 1 plus 2x to the half is equal to 1 plus x, and then the expansion of 1 plus 2x to the half is this thing up here, that thing up there, which is 1 plus x, take away half x squared, that should be a squared, sorry, plus half x cubed. If I expand those two things out, I get one lot of the bracket first of all, 1 plus x minus half x squared plus half x cubed, and then plus x lots of the bracket. So that gives me plus x squared, take away half x cubed plus half x to the 4. And looking through here, the cubed terms cancel with one another, and I'm left with 1 plus x. X is there, x is there, so that's 2 x's. I've got minus half x squared and an x squared, which gives me plus half x squared. Use those ones. I'm just ticking them just to make sure I've used everything up. And then I've got plus half x to the 4. I only want this up to x cubed, so I'm going to leave my answer as that. And I should probably change that to an approximation sign, because they are approximately the same, and that's what the question would be after. Obviously, we could change this to the x4 term. You'd have to expand this out to the x4 term because you'd have one lot of it. So if I wanted to change that question, I could do. So that's one type of thing you might come across. It might be that this is on the denominator. If it's on the denominator, just think, okay, well, it's the same as the reciprocal, so I just need to stick a minus sign in there. The other sort of question we're going to have a look at, we're going to use this again, is a quite common question which exam boards seem to like for some reason. I'm not quite sure why. No, I still don't really understand why they still they do this. Maybe it's something to do with numerical methods. So find an approximation for 1.2 to the half. Now, these sorts of questions will normally be, do a binomial expansion, and then they'll say, substitute some suitable value in to find an approximation for this. Just to confuse you further, it would have probably had it written like this, 1.2 square rooted. So if and Excel do like doing weirder things every year, if they had it just like this, all you need to say to yourself is saying, okay, well, is there some binomial expansion I know which could give me 1.2 in the bracket if I substituted the suitable value of x in? Well, there is. And you could do this a couple of different ways. However, we would like a relatively small value of x, and we want relatively small values of x because it will mean that as these terms get bigger, so we'll go x cubed, x4, obviously the smaller the value of x, the quicker those go to 0. So the first bit will give us a better approximation. So picking a small value of x is useful if you can. So find an approximation 1.2 to the half. Well, I'm going to say that I could use 1 plus 2x to the half. And I know that is approximately 1 plus x minus half x squared plus half x cubed. And if I let x be 0.1, then this then becomes 1 plus 0.2. If I stick 0.1 there, 2 lots of it is 0.2. Obviously 1 plus 0.2 is 1.2, and that's what we wanted, is approximately equal to 1 plus, okay, what's x? X is 0.1. 0.1 minus half of 0.1 squared plus half of 0.1 cubed. And that's equal to 1 plus 0.1. 0.1, where's my, let's do this on the calculator, make sure I get this right. 0.1 squared times by 0.5. Really could have done this on the head, couldn't I? Plus 1 over 2 thousandths. And if we add all that together, plus 0.1 minus 1 over 200 plus 1 over 2000, and that is equal to 1.0955. And if I do the square root of 1.2, let's hope this is right now, the square root of 1.2 is 1.09544. So it's really quite close. So that works pretty well. Like I said, it's really important that you try and pick a small value of x. If I picked something like, something like, well, I could have picked 0.2. If I picked 0.2, this wouldn't have gone quite so quickly. Also, there's different variants of this which you could pick, but if it was 1.7, I wouldn't pick 1 and 0.7. I'd pick 1 and 7x, and then let x equal 0.1. I could obviously let x be something even smaller and say this is 20 lots of something. But just in general, follow what the question asks you to do. If they decide to do something crazy like this, then just think of something that will give you a sensible expansion that will give you what you need. Okay, so can you guys finish off the rest of the exercise from yesterday? That's exercise 4A. I'm running out of space to write today. Exercise 4A. And I think you should probably try and get all of the rest of that one done. So that's 4 up to 9. And I will speak to you again tomorrow. Thanks very much. Bye-bye.